Hello friends, in today's video we are going to transition from something we already know called permutations into something that we're learning for the first time called combinations. The way we're going to start this is we're going to talk about 8 horses in a race. In how many different ways can they come in first through 8th place? So you think about these horses crossing the finish line. As soon as the first one crosses, well, there were 8 options for who could be the winner. But as soon as one of those 8 options is chosen as the winner, as soon as one horse crosses the finish line, 7 more remain, and those are the potential 2nd place winners. And then once that crosses the finish line, 6 remain to be the 3rd place winner, and so on. You can multiply all these together using the fundamental counting principle, or you could say, hey, I didn't need to make blanks anymore. I know the formula is NPR, meaning NPR is n factorial over n minus r factorial, meaning this is 8 factorial over 8 minus 8 factorial. So it's just 8 factorial over 0 factorial. 0 factorial is 1. Which is strange, but it is. So yeah, same thing both ways. We're going to say it's 8 factorial, which turns out to be 40,320. Next one, 8 horses could be first, 7 could be second, 6 could be third. Doesn't ask us to arrange 4th through 8th place, so we're just doing 8p3. So that's going to be 8 factorial over 8 minus 3 factorial, 8 factorial over 5 factorial. Quick way to expand that, 8, 7, 6, times 5, etc. And the bottom is just 5, etc. So that's crossing out, leaving just 8 times 7 times 6, which we knew over here was a good way to calculate that. That turns out to be 336 distinct ways that they could come in first through 3rd. But the 3rd question is different. It says, in how many ways can 3 horses be chosen? Doesn't matter what order you choose them. I just want to choose 3 horses. Could be that I'm choosing 3 horses to wear red. It could be that I'm choosing 3 horses to get their teeth cleaned. It's not about ranking. It's not about order. So while these first 2 problems were permutations by definitions are arrangements where the order matters, these are going to be combinations. And combinations are choices you can make where you don't care about ordering or arranging the things you chose. We don't care about the order of the horses if they're just being chosen to get their teeth cleaned. It's not like, haha, my teeth were cleaned 1 minute before yours. It's whatever. 3 horses got their teeth cleaned out of 8. So you might be able to predict that this number for C will be smaller than the other numbers we got. In A and B, when you permute things, when you order them, there's a lot of options. This one we're simply choosing, so there's not as many options. So what you do is you take your you take your answer for the permutation of 3 horses, and then you divide it to make it smaller, and you divide it by 3 factorial, because this number represents the number of ways you can arrange the 1st, 2nd, and 3rd place winners, or any 3 chosen horses. We don't want to arrange, we want to eliminate the arranging. So it's simply 336 divided by 3 factorial. 3 factorial is 6, because 3 times 2 times 1. So 56 is our answer for part C. Like I said, the combination of choosing any 3 horses, horse A, B, and C versus horse B, C, and F, any of those 8 horses, there's 56 options. So here's kind of a layout of NPR versus NCR. So you can guess stands for permutation versus combination. We already knew this formula, but then this one, NCR, is giving us a new formula. Here's 2 ways to think of it. You can think of it as the NCR formula just takes your previous answer and divides it by something extra. So you can literally take this formula and divide it by something extra. Or if you don't want to think of it this way, think of it as a standalone thing, you don't want to have to calculate permutations before combinations, then it's the same formula as you saw over here, except for what extra piece does it have? It has an extra r factorial on the bottom. Again, we're dividing out, we're eliminating some more options because we don't care about order. So you can read here, order important, order not important, formula, formula, and then some clue words that may help you. Let's do this with some letters. So the first one is asking about words. The second question is asking about just choosing letters, and it's not distinguishing that I need to make a word. So imagine these are like refrigerator tiles, and I need to choose between A, B, C, D, F, and I need to choose 3 of them. Let's say I chose this one, and this one. Let's say I wanted to spell bad. Is that a different word than dab? Yeah, those are two distinct words. So order matters when making words. So we are going to do 6p3 for this one. And order doesn't matter when I think about just a set of letter being chosen, because I'm not specifying if I want to spell or what I want to do with it. So choosing A, B, and D, like bad and like dab, that's the same thing as choosing B, then A, then D. It doesn't matter which order I do it in. It's just the 3 tiles that I chose. So this is 6C3. There's going to be fewer options for this. The number of permutations here, when I calculate it, is 120. This one is the same formula, except for you also divide by 3 factorial, r factorial. So it is going to be fewer. It's going to be divided by 6, so that leaves 20 options. If you don't care about the spelling, you just care about choosing 3 tiles. We can do the same thing with the runners. So why don't you pause it and choose between these between these 2 questions, which one is a permutation, which one is a combination. Then calculate, pause it. Hopefully you're able to tell that the permutation is this one, where they consider first, second, and third as 3 different things. It matters if you call this girl first place versus if you call this girl third place. Like, she's gonna care whether she's first or third. So that's a P. So that's 10p3. Let me show you on the calculator where that is. So P is gonna be under the probability menu of the math menu. So it's right there, the second option. So you make sure you put 10, and then you put NPR, and then you put 3. And so that's going to tell you that there's 720 ways to get a first place, second place, and third place winner out of 10 runners. And if you want to do a combination, like you just want to choose 3 of them to go on to the next round. Think about it as like literally you want 3 people to board the bus to get to the next race. You don't have to be petty and worry about who boards the bus first, second, or third. You just all got to get on the bus so you can all go to the next race. Combination is under math, probability, it's the third one. So this is 10C3, which we can predict is going to be smaller. It's going to be 3 factorial smaller, in fact. So divided by 6 is 120. I think you're getting the picture. I don't think I have to do too many more. But just to let you know, there is one more notation for combination that doesn't exist for permutation. So a combination can be thought of in these 2 ways that I already showed you, but also these formulas apply when you see this tall parentheses with an n on top and r on bottom. It looks sort of like it's a fraction, but there's no fraction symbol between the n and the r. It's just a way of saying NCR without saying the C. So if you see something like this, 7 on top, 3 on bottom, and those tall parentheses, all that means is 7C3. So you do the exact same formula as you have been for combinations. I want you to notice real quick that 7 factorial over 3 factorial and, oh shoot, I made a mistake. Over 3 factorial and 4 factorial is the same as when you do 7C4, because that would be 4 factorial over 7 minus 4 factorial. So this is 7, 3, 4, and this is 7, 4, 3, which you know should turn out the same because of the commutative property. So you'll notice that happens sometimes. All right, you guys are doing a nice job. Have a good day.